Uy!
Uy, may helmet ba kayo? Pahiram
Meron
naman.
naman ang hat dyan, oh.
Daddy, final
Nakalimutan ko helmet ko.
Headgear. Wala pa akong headgear.
Ang taas pala
Anong
natin,
ginagawa
no?
nyo?
Parang ang bilis mahulog.
Yung delivery ba natin nakadating na?
Uy, anong nangyari dun sa isa?
Uy!
Good morning, guys. So today we'll be
Hindi
talking
lang.
about steel construction and metal framing. It will be presented by
Francheska Balisi.
Martinez.
Averie, Pavon.
And Verniz, you.
To introduce you to steel construction and metal framing, structural steel construction and framing, it consists of steel beams and columns that form the vertical and horizontal elements of the structure. It is durable, reliable, cost-effective, and sustainable. It is adaptable to most architectural designs, and it can be used for skyscrapers, warehouses, bridges, and many other different building projects. Structural steel started in the 1800s, where there were these metals called ferrous metals, and there were three kinds of ferrous metals: wrought iron, cast iron, and steel. Wrought iron was a popular metal, and it was used at construction during that time. Cast iron was brittle and was only used for cooking, while steel was too expensive to produce, and so it was only used for smaller high-end products. In 1879, Sidney Thomas eliminated the phosphorus in the steel, and the result was improved quality of steel, improved quantity, and improved price of steel, which made it more accessible to the public. In the US, there was a great fire and it burned most of the timber structures. It happened in Chicago, and when they were about to rebuild the structures, the government enforced a law saying that buildings should be built with non-combustible materials such as brick, marble, and steel. In 1885, the first 10-story building was constructed out of a steel skeleton frame system with reinforced concrete. However, this building was torn down. In 1890, the Rand McNally building, which you can see in the slide, was the first all-steel framed skyscraper in the world. Next, in the 1900s, the United States was the world leader in steel production and development. They created office buildings, factories, railroads, and bridges with structural steel and metal framing. In 1928, the Chrysler Building was built, and it was and still remains the world's tallest all-steel supported building. And in 1940, steel became a regularly used material in building construction and framing until present day.
Metal roof framing details. A ridge beam is basically a structural member that is used to support the ends of the rafters. Its sizing depends on the span of the beam between supports and the amount of the roof load supported by the beam. A ridge board is a non-structural member that helps opposing rafter to rest against and connect to. It should be at least 1 inch nominal thickness and not less in depth than the cut end of the rafter. So webs are members that connect the top and the bottom cords to form the triangular pattern of a truss action. Cords are basically the outermost member that define the shape. It consists of two, the top cord and the bottom cord. Top cord is the member that establishes the upper edge of a truss, while the bottom cords establish the lower edge of a truss, carrying ceiling loads where it is applicable. Moving on to steel columns. Steel columns have good compressive strength, but have a tendency to bend under extreme loading. This can be due to their length, cross-sectional area, method of fixing, and shape of the section. So this is a sample drawing of a steel column. Steel connections. Steel joists are open web, lightweight steel trusses consisting of parallel cords and a triangulated wedge system, proportioned to span between bearing points. Steel joists are used on, on a variety of projects. There are examples for commercial, industrial, and other unique applications as well. So this is another example detail, floor connection detail. Welded joints. There consist of, here are three examples of welded joints. A fillet welded T-joint, a butt welded T-joint, and a compound welded T-joint. A fillet welded T-joint, such as T, are the most common connection in welded fabrication. A butt joint is the most universally used, while a compound weld is a combination of more than one type of weld in a single weld joint. Steel supports. Steel support systems plays a critical role in supporting a structure's cladding. These systems are made of structural steel, a specific category of steel used to produce construction materials, which is then molded into a particular shape. Here are the types of structural steel shapes. We have angle, L shape, which is composed of two legs that come together at 90-degree angle, typically used in floor systems because of the reduced structural depth. Bearing pile, or the H shape, works best in dense soil that offer most resistance at the tip. An individual pile can bear more than 1,000 tons of weight. Channel, or C shape, have a C-shaped cross-section and are cost-effective solutions for short to medium-span structures. Hollow steel section, or the HSS, is a metal profile that has a hollow tubular cross-section. It is used as exposed structural steel, staggered truss, and conventional truss structures. A pipe is a hollow cylindrical tube that comes in a variety of sizes. It is often used as steel pipes to meet the needs of oil, gas, and industry projects. I-beam. An I-beam, also known as an H-beam, this is widely used in the construction industry. A T is a load-bearing beam with a T-shaped cross-section. This can be used in floor constructions. So this is a sample drawing of steel column connection to stub column RC. Detailed drawing. Structural steel construction. Structural steel construction, isn't just for skyscrapers, large agricultural buildings, and garages. Steel is a versatile building material which has led to its inclusion in nearly every stage of the construction process. Some of the main benefits that make structural steel such a reliable choice are sustainability, affordability, and durability. Advantages of steel. First, its strength and durability. It's easy to fabricate and to be produced. It's fire resistant, pest and insect resistant, and it is also moisture and weather resistant. The disadvantages of using steel is this makes it susceptible to corrosion. It reduces flexibility on site, and steel has a high expansion rate with changing temperatures. Steel beam and metal column connection. So types of steel beam based on support. To summarize it, there are simply supported beams, fixed beams, overhanging beams, double overhanging beams, continuous beam, cantilever, and trussed beam. Here are the types of steel beam connections. We have the bolted frame connections and the bolted seated connections. Bolted frame steel beam connections. These are steel beams that are linked to supporting elements, whether it is steel girders or columns with web connection angle. Commonly, the connection is designed based on the load at the end of the beam. While the bolted seated steel beam connection have two major types, which includes unstiffened bolted seat connections and stiffened bolted seat connections. Yes, as you can see in the picture, to the left, that's the unstiffened bolted seat, and then to the right, the difference is just the the other one has a packing stiffener, while the the other one has none. Advantages of steel beams: they cannot be attacked by termites or rodents. No breakages, as steel can endure huge amounts of tensile stress. They provide high standard structural integrity and hence safety. They can be manufactured in your specific preference, and last but not least, they are resistant to corrosion and fire.
When designing for metal framing and metal decking systems, you need detailed drawings. Detailed drawings include the design drawings, structural steel requirements, and the design information needed, which include the forces acting on the connections. Next, the fabrication process for metal framing and metal decking. The first is material is cut to the proper length by use of sewing, shearing, or flame cutting. Next, fasteners, they're put in holes, and these holes are drilled. And lastly, for weld preparation, web openings, and clearances, they're all flame cut. Structural steel framing systems. There are 4 types of structural steel framing systems, which are wall bearing framing, skeletal framing, long span framing, and exposed structural joist framing. The first one we will be talking about is wall bearing framing. Wall bearing framing, it is when the interior or exterior wall, these two, are load bearing and they are used to carry the ends of the structural beam. And the structural beam carries the loads of the structures such as roof and floor loads. This wall bearing framing is the oldest and most common type of framing. Wall bearing framing should be strong enough to carry the vertical reactions from supported members and resist horizontal loads that are imposed on it. Wall bearing framing, it is more suitable for low-rise structures, and it is more suitable for low-rise structures because it cannot really carry the load on the succeeding floors because it's only carried by the walls. It can be applied to high-rise structures if reinforced steel and concrete are used. This is to help withstand the multiple stories on top. The steel members are placed on masonry walls using end steel plates and anchor bolts. So here, in this case, if there's a lower depth beams, meaning that the walls are a bit closer together, then higher ceilings may apply and near column spacings. However, if there are deep beam frames, then lower ceilings and further column spacing. There are 3 applications that we can use for wall bearing framing, which are single-story family homes, lintels used to support masonry, and one-story commercial light industrial type construction. So the first application, single-story family home, it's used to support the interior and exterior walls and floor loads with no intermediate supports. So just like in the image, the first image above, you can see that the wall is supporting the steel beam with no intermediate supports. The ends of beams are placed on the foundation walls. The foundation walls because those walls are the strongest. Next are lintels used to support masonry over wall openings of doors and windows because they place structural steel lintels on top to avoid the bricks from falling into the openings. Steel angle section used for brick walls and fabricated assembly for longer and heavier spans. So for types of lintels supporting masonry, you can see that type B, C, and E use a continuous plate. And in that continuous plates are used to close the bottom of the lintel, to join load-carrying beams into one unit, and pipe and bolt separators are used to hold two elements together. So B, C, and E. Next, the last application will be one-story. The next application will be one-story commercial and light industrial type construction. This is because it is this kind of framing, like again, I said that it's best used for low-rise structures. So if you're going to use it for warehouses, it should be light and one story only. The masonry exterior walls support the roof system, and it is practical for medium spans. For longer spans, over 12 meters, they either require thick outer walls and buttresses to be able to support the beam, and to be able to support the long beam, they need thick walls so that it can stand. Or steel columns, and lastly, intermediate columns in between these long spans. So it's either one of the three. For wall bearing framing, at the end of each beam, there are bearing plates. Bearing plates are required on the ends of all beams to rest on the walls. This limits the pressure on the masonry. So that when the beam is heavy, it limits the pressure on the wall. Wall plates are used when the beam is heavy and needs to be set by a steel corrector. Next, anchors. Anchors, government anchors are a type of anchors which are embedded into a hole in the web of a steel beam, generally used to anchor the beams on the masonry. So these anchors are used so that the beams will stick to the walls. The second type of structural steel framing is called skeleton framing. Skeleton framing is a steel framework that supports all the load of the structure, including the walls, so no more load-bearing walls. These walls are known as curtain walls or non-bearing. So this is the framing system that allows huge skyscrapers with curtain walls and huge windows. Steel is stronger than masonry, which allows for taller buildings with less floor area as compared to other building methods, making the skyscraper possible. So again, they can withstand the load of every floor, so it can be used for skyscrapers. So skeleton framing system, columns are moderately spaced to support the span of the beam. So as you can see here in the left image, you can see the layout of the columns and the beams, which are moderately placed. And by duplicating the details of a single bay, it allows for unlimited floor and roof area. And it can be built at any desired height. You can see that in the third image, you can see the different ways on how the steel beam connects to the column. So the first one is flexible plate, thin plate, and double angle plate. Skeleton framing systems have what they call spandrel beams, and spandrel beams are placed on the perimeter of the walls, and this reduces the change in the form caused by the loads. And shelf angles are placed on top of masonry over window openings. And these window openings, generally they place shelf angles on top of window openings that are 6 feet or wider. And the shelf angle supports the dead load of the wall and transfers it to the structural frame. Two methods for connecting the spandrel beam and the shelf angle. So in figure A here, we have a typical connection arrangement. When the leg of the angle shelf is 3 inches or less below the flange of the spandrel beam. So the beam, if you can see in my pointer, the beam has two two flanges, the top and the bottom flange. So we're talking about the bottom flange. So it's 3 inches or less below the bottom flange of the spandrel beam. Next is figure B, corresponding arrangement when leg of the shelf angle is more than 3 inches below the bottom flange. So you can see it here, this one. And lastly, figure C is practical and simple. Figure C over here, practical and simple. If elevation and alignment will conform to the permitted steel framework tolerance.
The third structural steel framing system is long span framing system. In the late 20th century, structures that require visibility for a large audience encounter structural problems. Thus, a long span framing system was implemented. These framing systems create unobstructed column-free spaces greater than 30 meters for a variety of functions, such as auditoriums, stadiums, theaters, hangars, and gymnasiums. These framing systems can provide greater clear distance between supports that can be supplied by beams and columns. The following are used in long span framing construction. First is girders. Girders are the main horizontal support beams of a structure used in construction. It also serves as a support beam to the smaller beams. They often have an I-beam cross-section, such as the one in the picture, composed of two load-bearing flanges separated by a stabilizing web. This structure is the usual choice where depths are limited. Here are different types of girders. Welded girders. Welded girders are composed of 3 plates. They are easily fabricated and efficient. It is also lightweight compared to other girders. Second is the hybrid girder. Hybrid girders are economical for heavy loading and long spans, and it is usually used in bridge work. The third is heavy girders. Heavy girders use cover-plated T-sections, a pair of girder diaphragm together to share the load. Fourth is the box girders. They are also known as tubular girder. They form an enclosed tube with multiple walls, and compared to I-beams, it resists torsion better. When depth limits permit, the more economical way of spanning long distances is through the use of trusses. Trusses are hollowed-out beams that have members that are subject to axial compression and tension. The general types of trusses are the Pratt truss, the Warren truss, and the Howe truss. The Pratt truss has diagonal members which are slanted towards the middle of the bridge span like this, while the Warren truss has a series of isosceles and equilateral triangles. And the Howe truss is the opposite of Pratt truss, which has diagonal members which are slanting away the middle of the bridge span. In most buildings, Pratt-Warren or a combination of the Pratt and Warren truss are used. The Howe truss is rarely used because steel may not handle the compressive stress of the structure. So Pratt and Warren truss, a combination of both trusses, is used to increase the span length of a structure. The Pratt and Warren truss may be used as a principal supporting members in floor and roof framing. This type of truss has a top chord and is not parallel to the bottom chord to provide drainage for the flat roofs. Another type of truss is the Villarendeel truss. It is characterized by having only vertical members between the top and bottom chords, and it enables a footbridge to span large distances. It is statistically indeterminate structure and present an attractive look. Next is the bowstring truss, which is often used in bridge building and less in industrial buildings. It consists of an arc beam joined by a straight beam with diagonal support members. It is used to span wide column-free spaces. Think truss is commonly used in residential homes and bridges. It is characterized by having multiple diagonal members projecting down from the top of the very post at a variety of angles. It actually originated as a bridge truss, although the current use in bridges is rare. Scissors truss is primarily used in buildings, and of course it has a similar appearance to an open pair of scissors. Scissors trusses are used almost entirely in building construction to support a pitched roof, where a sloping or raised ceiling surface is desired. Long span joists are light trusses closely spaced to support floors and flat roofs. They have parallel or sloping chords and use both Pratt and Warren truss, wherein their webs are fabricators. It conforms standard specifications and to standard loading. For truss applications for churches, here in this example, the architect used a scissor truss for the ceiling. And then for this auditorium, open auditorium, Warren truss is used. And for this industrial building, it's more of a warehouse, Pratt truss was used. For steel arches are curved lengths of steel used for very large spans. It has a bent framing that takes the form of a solid or open web arches. So the different types of arches. One is the three-hinged arch, wherein it consists of a curved beam mounted on two fixed supports. It has a crown hinge located at a crown, and the two here fixed hinges support the curved beam, absorb the horizontal and vertical forces that they are known as abutment hinges. Abutment is a structure built to support the lateral pressure of an arch or span. Fixed arches, unlike one-hinged arches and two-hinged arches, which are named after their definitions. Fixed arches are hingeless arch trusses. For rigid framed arches are stiff structures that use beam-to-column connections that are usually evaluated and tested to relieve bending moment. Examples of rigid frames are the following: single bent, continuous frame, and two-hinged. Hung span beams are an arrangement of cantilevered suspension spans that has been proven economically and highly efficient. The layout is made to obtain uniform load of all spans.
Okay, so for architectural, number 4, architecturally exposed structural steel framing. It's also known as AESS. So this is the type of steel that is designed to be exposed. It is designed to be exposed and part of the architectural design, but it should also be strong enough to hold the building. So these are the steel that you see in airports and in other huge architectural structures. This type of framing, it requires assembling of members and their joints. And it also requires shear and moment resistance, balance, form, symmetry, and economy because it needs to be strong and it is also expensive to construct. AESS is usually connected by welds and bolts, as you can see in the first image and in the second image.
Another structural steel framing system is the metal floor joist framing. Here's an example, and here's a detail of it. So, metal floor joist framing spans up to 33 feet. The hole size ranges from 4 to 1/4 inches to 10 inches. Its superior strength permits a wider on-center spacing, and it can be pre-cut to the exact specifications given by the engineer and architect. And here are the standard hole spacing. So steel joists are lengths of steel supporting parts of the structure of a building. It is usually arranged in a parallel series manner and provides efficient framing for supporting floors and ceiling. Since steel joists are lighter than wooden trusses, the size of the supporting structural elements as well as the size of the building's foundation can be reduced for cost efficiency, which makes it economical and lightweight with high strength-to-weight ratio. Here are different types of steel joists. First is the open web steel joist, which is primarily designed to support floors and roofs of buildings. Uh, the available depths ranges from 8 to 30 inches and can span up to 60 feet in length. There's the long span steel joist, which is even longer than the web steel joist, and its available depths ranges from 18 to 48 inches and can span up to 96 feet in length. Then there's deep long span steel joist, which is even longer than the long span steel joist, and its available depths ranges from 52 inches to 72 inches and can span up to 144 feet in length. Cold formed metal joists are used in the construction of metal joist framing systems. The tracks used at top and bottom of wall framing and at the ends of floor framing to hold studs or joists. And then there's the C-studs and joists used as vertical studs and horizontal rafters. Here are the standard sizes of these steel materials, and then there's also an example designation.
Floor framing and roof systems. Floor framing design and considerations. Load carrying capacity, durability, fire resistance, dead weight, overall depth, facility for installing power, facility for installing air conditioning, sound transmission, and maintenance and construction time. Principal factors on proportioning of members carrying compressive forces are overall column buckling, local buckling, and cross-section area. W shape is primarily used for large simple structures such as garages, large agricultural buildings, warehouses, and even high-rise buildings. It can also cater to a wide range of other types of development such as offices, factories, schools, public buildings, and even residential dwellings. Advantages are strength, durability, easy fabrication, fire resistance, pest and insect resistance, moisture and weather resistance. Disadvantages are thermal conductivity, reduced flexibility on site, and supporting structures. Here are the local suppliers in the Philippines. JS Steel and PPR Light Steel Framing System are most commonly known suppliers here in the Philippines. JS Steel Industries is a light steel frame provider in the Philippines. They offer light steel frames that are made out of galvanized iron. And here are their contact details. PPR Light Steel Framing System. They manufacture numerous framing members for both structural and non-structural framing in the Philippines. They are known for their lightweight and easy to install products. Steel Frame Philippines and Steel Center Philippines are also local suppliers here in the Philippines. Case studies. San Juanico Bridge in Samar. San Juanico Bridge stretches from Samar to Leyte across the San Juanico Strait in the Philippines. Its longest length is a steel girder, viaduct on reinforced concrete piers, and its main span is an arc-shaped truss design. The road construction is the longest bridge in the Philippines, spanning across a body of water measuring 2,164 meters in total length. It has 43 steel spans with the primary span measuring 192 meters. The bridge abutments are founded on steel H-piles, while its piers are rock-seated pedestals built using the pre-pack method, having a single cylindrical shafts and tapered cantilevered copings. Another case study is the Fort Bridge in Scotland. It opened in 1890. The Fort Bridge is a Scottish icon that is recognized all over the world, as it is most famous for its cantilever designs. It's the world's first major steel structure. The Fort Bridge represents a key milestone in the history of modern railway civil engineering, and it holds the record as the world's longest cantilever bridge. 53,000 tons of steel and 6.5 million rivets were used to construct the Fort Bridge. Last case study is the National Award HL23 in New York. It is located in Manhattan's West Chelsea district. It is a 14-story and ultra-luxury residential building. Its architect is Neil M. Denari Architects, Los Angeles. Its structural engineer is De Simone Consulting Engineers, New York. It is clad with a mega panel glass and stainless steel curtain wall system. The project's distinct form comes from the dramatic sloping of the south and east facades. A steel plate shear wall A steel plate shear wall system, unique in New York City, provided the project with benefits of increased stiffness and smaller dimension, both tremendous benefits for this site. This required special care during the design of the exposed connections of the perimeter steel diagonal braces to perimeter steel beams. It was achieved by replacing the traditional use of multiple bolts, gusset plates, with the end plates hidden in the concrete metal deck slab for intermediate diagonal braces, and with the pin end connection for end braces.
Yay! Construction!
Yay!
Construction!
Na.
Hand over the key to the owner.
Yee!
Nice one, guys.
Nice one. Okay, guys. That concludes our presentation on steel construction and metal framing. Thanks for listening.
Thank you.
Bye.
Bye.
Stay safe.